Hello everyone. Now I am going to start the name reaction for both JEE and always as well as NEET exam also the important name reactions. So today I am going to start the first name reaction is Aldol condensation reaction. Aldol condensation reaction. In this series of name reaction, I will discuss some reaction, some reaction whose mechanism is important, and some reaction whose mechanism is not important. Of this reaction, I will discuss only direct method for this reaction, which has no need of mechanism, and some PYQ with that particular reaction. After completing that reaction, I will discuss its PYQ in the same video, and in each video I will complete one name reaction. So today now I am going to start the aldol condensation reaction. First, what is meaning of aldol and condensation? Condensation means two molecules combines and leave and which knock out some small molecules like water, ethanol, and some other maybe other also. This means condensation. What is aldol? If I tell you all, if I discuss all the reaction, then you can easily aldol what is aldol. First, I will start the reaction. So first, what is the requirement? So requirement is that NaOH, or we can say base, any base like NaOH, KOH, sodium carbonate, Na2CO3, potassium carbonate, K2CO3 are used here as a reagent. Second one is aldehyde or ketone has a alpha hydrogen atom. Alpha hydrogen atom. Aldehyde or ketone group. Ketone. So first, what is alpha hydrogen atom? So let I draw here any aldehyde. Here is equal to R. R is equal to maybe H, or another alkyl group like CH3, CH2, CH3, whatever it will be. But our focus is on that carbon. So what is alpha carbon atom? So this is the carbon atom, and adjacent to that carbon is R is equal to maybe H or CH3 or C2, CH3. Our focus is on that carbon, which is adjacent to the carbonyl carbon. So this is carbonyl carbon, and adjacent to carbonyl carbon is alpha carbon. And suppose this is the alpha carbon, this is the beta carbon, this is alpha, beta, and this is the gamma carbon atom. So this is the alpha carbon atom, and hydrogen to attach to that alpha carbon is called as alpha hydrogen atom. Let's suppose here one is this is the alpha hydrogen atom. So the first condition is base is used, and second one is alpha hydrogen atom should be there. Now let's see here. What is the name of that compound? Acetaldehyde. Is it has a alpha hydrogen atom? Yes. Which one? This one or this one? This one is the alpha hydrogen atom. This is not a alpha hydrogen atom. This is not a alpha hydrogen atom. Now tell me, is this what is the name of that compound? Formaldehyde. Is it has a alpha hydrogen atom? No, it has no alpha hydrogen atom. Now another one example is it has a alpha hydrogen atom? No, it has also not alpha hydrogen atom. So I hope you will understand that which is alpha hydrogen atom, which is Beta hydrogen atom is carbon attached beta carbon hydrogen atom to hydrogen atom attached to a beta carbon atom. So now the next, let's see the reaction. Let I am taking here CH3 C double bond OH acetaldehyde in presence of base. It gives CH3 CHOH CH2 CHS, which on this reaction is called aldol, and if we heated this further, water is removed out and product is that CH3 CH double bond CH CHA. This is the condensation reaction, and the overall reaction is called as aldol condensation reaction. Here two molecules are used of acetaldehyde. So now let's see the mechanism. Now let's take the one molecule of acetaldehyde. NaOH from NaOH OH minus comes. Let's CH2, and this is the alpha hydrogen atom. This base takes this alpha hydrogen atom, which is acidic in nature. How it is acidic in nature? Let's see. What will become here? CH2 minus double bond OH. This negative charge is well stabilized by resonance with that carbon pi bond of carbonyl group. What is here? CH2 double bond O minus H, and this negative charge is will stabilized by oxygen, because oxygen is a highly electronegative atom. So this negative is well stabilized by resonance. So this hydrogen atom is a acidic in nature. That's why this base takes that acidic hydrogen atom, which is at alpha position. Now what happens next? Let another molecule of acetaldehyde comes in the picture. Let if you see here, if these structures are in equilibrium, so which will act on, let's see, this carbon is an electron deficient, because how we can draw it? CH3 here O minus partial negative, here partial positive charge is come. So partial positive charge on the charge comes on that carbon, so it is partially, so it is electropositive. So here nucleophile can attack on that carbon, but which will attack? This carbon negative will attack, or this oxygen atom will, oxygen negative will attack. So here carbon bond is more stronger than carbon oxygen bond, because carbon bond is not non-polar and carbon oxygen bond is more polar. So non-polar bond is more strong, so therefore this oxygen is, sorry, this negative charge on oxygen carbon will attack on that carbon. This bonds open. So what happens here? Here between same and O minus or H face this thing. So this part, and finally from water, H, I am writing like that H, this takes that H plus and forms the final product. Oh, one thing I missed that. Sorry, I missed one carbon here. What will be formed? Here double bond O H is magnesium. Here CH2 I miss. The CH2 will attack on that carbon. Here O minus will form. Here CH3 and here H. So this oxygen negative will take proton from water. Water will comes from here. If you see here OH minus and H will form, water will remove out. So this will take H plus from water, And what will be the final product? CH2 OH CH3. So this is till now this is the only aldol reaction. So if you heat it, what will happen? From here OH, and here from here H will be removed out and water is removed out. So this compound will be formed. So first, sometimes the name of that compound will be asked. What is name of that compound? Beta hydroxy carbonyl compound, and this is the alpha beta unsaturated. This is the alpha carbon, this is the beta carbon. Alpha beta unsaturated, 1 minute please. Alpha beta unsaturated carbonyl compound. Why it will happen? Because this is little much more stable than this, because this double bond is conjugation with carbonyl pi bond or carbonyl group. So this is the overall mechanism of that Aldol condensation reaction. So we formed that product. What will be the name? What is the name of that product? This is the common name from common name system. This is the crotonaldehyde. Is the name of that compound. Let one important thing that in dehydration here, what is here? I am writing again here in neatly. CH OH CH3. Here dehydration is, dehydration follows which mechanism? Means elimination is there, but which type of E1, E2 or E1CB? It means here first OH minus takes that proton and forms negative charge, which is which is stabilized by carbonyl carbon. CH minus, yes, CHOH, and SCH3 where H is there. And this negative charge will stabilize by that carbon carbon. After that, what happened? This OH protonated by water. So now this becomes very good living group. So this, therefore this negative charge comes here, and this group leaves out, and your final product is formed. Alpha beta and saturated carbon carbon. So which one is this mechanism called? E1CB. E1CB mechanism. This, so many times examiner will you ask, dehydration in aldol condensation reaction follows which mechanism? So answer is E1CB mechanism. Now this is the mechanism, but in exam question is asked, then there is no enough time to write all the mechanisms. So you should have to know the direct method. What is direct method? How can find out the product in short trick? So let's see here. It is our first starting material in our vocation. Here CH3, this is also same. NaOH is given, heat also is given. Simply, what you have to do? Two hydrogens from that alpha carbon, and this oxygen removes out. That I am writing here. This group leaves out. short form C. You got it? This I hope you understand the shortest method. But sometimes examiner will give no heat will be not given. Then what you have to do? That I am writing again here. Only NaOH base will give. Then you have to do what? Only one hydrogen atom transfer to this OH and form bond between this carbon and this carbon. So CH3 here OH will be formed and this carbon makes bond with that carbon. So CH2 C double bond OH. So this will be the your product. If heat or delta is not given in the question. Now let for practice only let's see one another example of that reaction. Acid acetone CH3 double bond O CH3 NaOH delta what will be the product two acetone molecule. It has here also beta alpha hydrogen atom here also alpha hydrogen atom. You have to do only one side. So what will happen CH3 C double bond O CH double bond O. This is binded with will be binded with this carbon C here CH3 CH3. By direct method this will be the product. But what is the mechanism? Again for practice I am writing again here. The mechanism is OH minus will take proton from this alpha hydrogen atom. So what will be formed? CH3 double bond O CH2 minus. Another acetone molecule is there. It has a electron deficient carbonyl carbon. This will attack on that carbonyl carbon. This bond will be open. So what will happen? CH3 double bond O CH2 O minus CH3 and here one CH3. After workup means water this takes proton from water. Now what will be formed? Double bond O here CH2 here OH CH3 and CH3 is formed. And after if heat is given in the question then OH from that carbon and H from that carbon will be leaves out and forms alpha beta unsaturated carbonyl compound. This is our final product of formula from acetone. So let's take use here another one question is is it will be given aldol condensation reaction? No, because it doesn't have any alpha hydrogen atom. If I added this with let's suppose acetaldehyde, is it will be give aldol condensation reaction? Yes, because it has a alpha hydrogen atom. So base will take proton from that alpha hydrogen from here and this carbanion will attack on that carbonyl carbon. So how will be our product? CH2 minus will attack on if I am writing shortly benzene ring in phenyl. This will attack on there, this bond will open and what is formed like that CH2 O minus phenyl and after workup that is this will take proton from water CH2 OH phenyl. If heat is given water will be removed out. I think will practice now for dehydrating it will become double bond here pH. So this is our final product. So this is called as cross aldol condensation reaction. From here Some example can you give me? Some example also like formaldehyde is also can be used for cross aldol condensation. Sometimes what is happening that sometimes case will become like that. Let's suppose one acetaldehyde plus acetone is used. Then question will be how many product will be formed in given aldol condensation reaction with self aldol condensation plus cross aldol condensation. So simply this is acetaldehyde, this is acetone. Acetaldehyde, firstly see, first we will make self aldol condensation of acetaldehyde with itself. So one product will be formed. One product of that self aldol condensation will be formed. So what will be that product? I am writing here, not going to in detail mechanism. Only question we want, only question answer of that question. So this is a product of that self aldol condensation. Self aldol condensation of that product of acetone. Self aldol condensation product of acetone is what will be here previously also this one. So CH3 double bond O CH2 double bond CH3 and CH3. Here two products we got it. Now attention. Base. Base will take proton from here also. Base will take proton from here also. So if base takes proton from alpha hydrogen of acetone, then what will happen? CH3 double bond O CH2 minus. It will attack on carbonyl carbon of acetaldehyde. This will attack on there. This bond will open. And what is formula? CH3 double bond O CH2 O minus CH3. After work up, hydrogen will come here. After dehydration, double bond O CH double bond CH CH3. One product is this. Now another one next probability is that base will take proton from that alpha carbon of acetaldehyde also. If we made this probability, then let's see H double bond O CH2 minus will attack on carbonyl carbon of acetone. This bond will open. Now what is formula? H double bond O CH2 O minus, here one CH3, here one CH3. After workup, H will become, and after dehydration, what will be product? H double bond O CH double bond CH3 CH3. This. So how many types of product is formed? If you see here four products are here. 1, 2, 3, 4. No, none of them is similar product. So here four types of product will be formed. So in numerical answer type question it becomes like if we make aldol condensation reaction of that combination, how many types of product will be formed? Then your answer should be 4. Now you tell me if our reactant is like that. That here CH3, CH3, it has only one alpha hydrogen atom. Then what will happen? Base will take that proton. Here CH3, here CH3, here minus. This negative will attack on carbonyl carbon. This bond will open. O minus, this will come after work up OH will be formed. Now if you see here, I'm writing product this neatly. Let if you see here, how can I write this? 1 2 3 4, 1 2 3 4, 2 group 4 is here. If heat is also given, is here dehydration will be happen or not? Let here there is no another alpha hydrogen atom to dehydrate, so therefore dehydration will not happen. Product will be same as it is, because if you can see that here is the hydrogen atom and water will be removed out from here, but it is not possible because reaction is happening this in aldol condensation reaction, because if bond is formed here, then this is in resonance with that pi bond of carbonyl carbon, so it is stable. But here double bond will not be formed, because if you go through the mechanism I already discussed, it goes through E1CB mechanism. E1CB mechanism and E1CB mechanism, let I am writing again here. Base will take proton base will take proton from here, and this negative charge is well stabilized by carbonyl carbon. But if base is taken from here and this negative charge is not stable, therefore it will not go through E1CB mechanism and no dehydration will occur, so here dehydration will not be occur. So this case you should have to remember. Now comes to the PYQ of that aldol condensation reaction. The question is, which of the following is the product of aldol condensation reaction? The question is, which of the following is product of aldol condensation reaction? And this question is asked in IIT mains 2013. This is the PYQ of IIT mains 2013. So, which of the following product is the product of aldol condensation? Aldol condensation reaction, or simply you can say not condensation, only aldol reaction. Yeah, because condensation is not happen here, because here OH is present. So how can you find out which is the product of aldol reaction? Simply beta hydroxycarbonyl compound is our product in every aldol reaction. In every, remember always, our product in aldol reaction is beta hydroxy, and aldol condensation alpha beta and substitution. You can see here which one is the beta hydroxy. Let comes to the first option here, alpha carbon, this is alpha hydroxy, so this is also not our product. Here this is carbonyl carbon, this is alpha, this is also alpha hydroxy, not. That if you see here, this is carbonyl, this is alpha, this is beta. Yes, this is our correct answer. If you see here, this is carbonyl, this is alpha, beta, gamma, this is gamma, this is our also not answer, our answer. So third option is correct of that question. This is the beta hydroxy carbonyl compound. The correct option should be third. Now again, one PYQ, one question is asked on the basis of aldol condensation reaction in JEE Advanced 2012. Question is that the number of aldol reactions that occurs in the given transformation reaction. Question is what? So the question is number of aldol reaction occurs in the given transformation. The given reaction is this: acetaldehyde is reacted with 4 molecules of formaldehyde in presence of concentrated NaOH, gives this type of product. So how you can find, this is looking like very hard question and complicated product, and how you can find out the how many numbers of aldol reaction will be formed. You will be make, here is no alpha hydrogen atom, base will take alpha hydrogen from here, and again base will take second form you will form first product in, then again it has alpha hydrogen atom. Base will take that second alpha hydrogen atom, attacks on the second molecule of formaldehyde, and we will form all the product. And it is very time consuming, but it is a simple trick here is for that question. How many number of alpha hydrogen atom here? You will see here three alpha hydrogen atom there. Here is no any alpha hydrogen. Here is only three. So therefore, how many number of aldol reaction will be happen here? Three. Three alpha hydrogen, three aldol reaction will be simply. So here option A is correct of that question. And how these products will be formed? First, three aldol reaction will be formed, and next one Cannizzaro reaction is formed where no any alpha hydrogen atom is present, then Cannizzaro reaction is happening. But I am not telling discussing about now Cannizzaro reaction because this is little much different than aldol reaction. I will continue Cannizzaro reaction in the next video. Then I will discuss how will be this reaction will happen, and in detail mechanism I will discuss this reaction. But from here simply we can say three numbers of aldol reaction will be formed, will be occurs in that transformation. So our correct option is A, and the correct answer is 3. So this is overall aldol condensation reaction, and we will go on it also. I hope you are well understanding that you have well understand that aldol condensation reaction. In the next video, I will continue the Cannizzaro reaction. Then thank you guys. We will see you in next video.